Right, good day everyone. Before I start today's topic, I'm going to quickly recap what we have learned so far. Okay, if you look at the screen here, we have learned about the simple graph and the multi-graph. Okay, multi-graph is the graph with the multiple edges and the loops. Right. Okay, we also learned about the directed graph and the undirected graph. Okay, so as you can see on the screen here, the directed graph is made up of the directed edges and vice versa for the undirected graph. Okay, so today we are going to talk about the weighted and the unweighted graph. So consider this graph, right? Okay, look at the graph on the screen. Okay, as you can see that every edges are assigned with a value. Okay, are assigned with a value. Okay, for example, we have how many vertices here? Okay, we have 5 vertices here. Okay, v1, v2, v3, v4, and v5. Okay, if you take two adjacent vertices as an example, for example v1 and v2, we can see that from v1 to v2 it takes 600 meter. So 600 meter is a value that assigned to the edges connecting v1 to v2. Right? Meter stands for the distance, right? So the values can be anything, can carry any meaning. It can goes from distance to time to current, as in the electricity, and or the cost and etc. Okay, many meaning here, many meaning there. All right. So let's take a look at the example of the question that come up with the weighted and unweighted graph. The first example, okay, draw a weighted graph connecting the tourist attraction in Malacca. The distances between the attractions are given. Okay, first we have to determine how many attractions are there, and hence determine how many vertices are there that we need to draw. Okay, A, B, C, D, E, and F. Okay, 6 vertices. Okay, 6 vertices, which I'm going to mark down there. A, B, C, D, E, and F. Right, so I'm going to use the black pen to connect them based on the table. A and B, 1 kilometer. A to C, 1.5 kilometer. D to B, 1.8 kilometer. D to E, 1.9 kilometer. And the last one, E to F, 2.6 kilometer. Okay, this is not a directed graph. Okay, this is a simple graph. Therefore, this is your answer. The diagram on the right shows one-way path that Izaro can choose for his running practice. Okay, vertex V1 is the starting position, and vertex V5 is the ending position before he goes home. Okay, determine the shortest distance from V1 to V5, the longest distance from V1 to V5, and the vertices that must pass through if the distance of the one-way run is between 1.4 km and 2.1 km. So this is more like try and error before it gets the answer, right? So let's go for the A, the shortest distance. So the brain tells me that to go for the shortest distance, you pass through as few vertices as possible, right? So this is what I think that will work. Right, do a mental calculation for the distance. Okay, you should be able to get the answer. Alright, so from V1 to V5, if the path that I choose is correct, we go for V1 to V2 to V5. So the total distance that cover is 600 meter plus 500 meter. Right, So the answer is 1100 meter. Okay, this is the shortest distance, right? Right, next, the longest distance from V1 to V5. Okay, so the longest distance, okay, by right, it should be passing as many vertices as possible, right? So from V1 to V2, V3, V4, and V5. Okay, this should cover the longest distance, right? So let's go for that. Calculate the total distance cover. Okay, 600 meter plus 900 meter plus 500 meter and plus 500 meter. So total answer is 2500 meter. Okay, next one, the vertices that must be passed through if the distance of the one-way ride is between 1.4 km and 2.1 km. So again, try and error method. The answer for the shortest distance and the longest distance is no longer our consideration. So we have to list down other path that he may run. So V1, V3, V4, and V5. Okay, this is another possibility. There is more than 1.4 but less than 2.1. Okay, another possibility, V1, V2, V4, and V5. Right, this is another possibility which fall between 1.4 and 2.1. So the common vertices that he must pass through regardless the path that he takes is V1, V4, and V5. Right, so the answer is V1, V4, and V5. Okay, next example, find the optimum cost to travel from A to C. Okay, so this is A, this is C. Okay, we have to be minded with the direction taken. So a lot of possibility. Okay, I'm going to highlight it to find the best. When I say optimum, okay, when the question says optimum, it means the least cost, right? The least cost. So if I go from A, B to C, okay, A, B, C, the answer is 10, right? Okay, is there any other possibility? If I go for ABDC, ABDC is 12. Okay, it's 12. Okay, we have to find the least cost, right? So this is not possible. If I go for ADC, ADC is 6 plus 1, 7, right? Okay, it seems this is a promising answer. Any other possible answer? So you can do your mental calculation. So the final answer is we go from A to D to C. Okay, this is the optimum cost.